Hey everyone, welcome to Geometry, Section 12.1, Tangent Lines. So this starts our last chapter and it's all about circles. So by the end of this lesson, you should be able to understand what a tangent line is to a circle, find missing angle measurements, and find missing length measurements. So let's start off with a little bit of vocabulary. First off, let's say we have a circle here, and then we have a line. Together, that makes a line and a circle. But what if I kind of move that line a little bit so that it goes through the circle? A line that goes through the circle is called a secant, which we'll talk more about secants later. But what if I move that line again so that it's just barely touching the circle? That line is called a tangent. And that's what we're going to focus on today, is tangent lines and circles. So let's go ahead and put some points in here. Here we have P as the center of the circle, so it's circle P. And then the line is line AB. So we could say that line AB is tangent to circle P. Another piece of vocabulary is the point of tangency. So if AB is a tangent line, then that means point B is the point of tangency. That's where that line hits the circle. Now, something that's in your book referred to as Theorem 12.1 basically says if you have a situation like this where you have a tangent line, and you draw a radius to the point of tangency. So I'm going to draw a radius from point P to point B. But if I draw a radius to a tangent, then that radius will be perpendicular to the tangent line. And that's going to be very crucial for anything that we do in this section, is that a radius and a tangent are always going to be perpendicular. So let's go ahead and use that to find some missing angle measurements. So here we have a diagram. We have a circle and it has two tangents. So I've got a tangent up here and a tangent down there. Now, key thing that we just talked about was that when you have a tangent to a circle, it makes right angles. So here we have two right angles, and that's going to help us a lot in finding x. So I've got two right angles. I've got a 160, and so how can I figure out what x is? Well, first thing you might take a look at is all those angles are in that quadrilateral. So how many degrees does a quadrilateral have? Some people might say, oh, it's 180. That's a triangle. But a quadrilateral, well, we learned this back a few chapters. If you take 180 times n minus 2, a quadrilateral has 4 sides. So 4 minus 2 is 2. 180 times 2 is 360. So all quadrilaterals will have 360 degrees. Or you might have just remembered a quadrilateral has 360 degrees. So now that I've got 360 as the sum of all those angles, I can just take those three angles that I have, the 160, the 90, and the 90, add them up and subtract it from 360. So that's basically 360 minus 340, which just makes x 20 degrees. Okay? Very important to know that, but you can't know that unless you know that those two angles are 90 degrees. Here's another one. Here I have a triangle inside a circle. One angle is x minus 19. The other angle is 2x plus 13. And that third angle that has no label on it, we should know that that's 90 degrees. So a triangle has 180 degrees in it. So I could say that x minus 19 plus 2x plus 13 plus 90 equals 180. And that's my equation. Let's go ahead and collect some like terms here. So 3x plus 84 equals 180. Subtract the 84, divide by 3, and we get x equals 32. Now make sure you pay attention to what the question is asking. If it just says find x, you found x. But what if it says what are all the angles in the triangle? Then we got to take that 32 and plug it in. So for that top angle, I get 32 minus 19, which is 13 degrees. I can take that 32, plug it into that bottom angle. 32 times 2 is 64. 64 plus 13 is 77. And then, of course, the only reason we were able to do that is because that third angle is a right angle. So if you add up 13, 77, and 90, does that make 180? It sure does. That's proof that we did it correctly. So now let's use the fact that those make right angles to find missing lengths. So here we have a triangle, and one leg is the radius of the circle, Another leg goes from the point of tangency out into the middle of space. And then the hypotenuse goes from the center of the circle out to that point in the middle of space. Now here's a heads up, that 18 is not the full length of the hypotenuse. It couldn't be, because the hypotenuse has to be the longest side. And if this side is 24, there's no way the hypotenuse is 18. Okay, the 18 is just from the edge of the circle on out to this point in space. Okay, so to get the full hypotenuse, the other part of the hypotenuse from the edge of the circle to the center is the radius. And we already know that the radius is x. So that makes the full hypotenuse x plus 18. And again, because this is a right angle right here, we know we can use some Pythagorean theorem to find those missing lengths. So let's set this up in some Pythagorean theorem. X squared plus 24 squared equals x plus 18 squared. Now, quick reminder, you don't just square the x and square the 18. When you square x plus 18, you have to write it out side by side and then FOIL it together. So x times 18, 18 times x, and 18 times 18. And you end up getting x squared plus 36x plus 342. Now, we are in luck because both sides of the equation have x squared in them. So those two x squareds could just cancel out. So now we have a very simple equation. Let's subtract the 324 from both sides. Divide by 36, and we get that x equals 7. All right, let's take a look at another triangle. And again, because it goes from the center to the edge of the circle, that makes that a radius, and 10 is a tangent. So this has to be a right triangle. So in this right triangle, it says find the radius. Well, before we find the radius, let's just figure out the missing side of this triangle. Let's call it x. Throw that into some Pythagorean theorem. So x squared plus 10 squared equals 26 squared. Work that on out. Subtract the 100. Square root both sides, and you get x equals 24. So now, let's make sure that we answer what they asked. It says find the radius. Well, that 24 is the diameter, so that makes each radius 12. Let's do one more problem where we find the missing lengths. Let's have a problem very similar to one that we've already seen, but this involves another idea, and the fact is that if you have two tangents that originate from the same point, so here I've got two tangents coming from this point here, those two tangents are going to be congruent. Okay, there's no way around it. Those two have to be the exact same length if they both start from that point and end up touching the same circle. So, what if you had something like this? Could you solve for x? Well, it should be as easy as setting the 4x minus 17 equal to 3x plus 8. So we set up that equation, do a little bit of algebra, subtract the 3x, let's add the 17, and we get x equals 25. So if the question says find x, we're all done. And the main idea I want you to get from this is that two tangents that come from the same point have to be congruent. Now, what if instead of finding x, what if they said find the perimeter of the quadrilateral? So they want us to add up all four sides of that quadrilateral. Well, now that we know that x is 25, we can go ahead and plug those in. So 4 times 25 minus 17, see that's 100 minus 17, that's going to be 83. 3 times 25 is 75. 75 plus 8 is 83. Well, it's good that those match because we just said that they had to be congruent. And if this radius is 25, that means the other radius has to be 25. So to find the perimeter, all I have to do is just add all those things up. So 25 plus 25 plus 83 plus 83 gives us a grand total of 216. So the two main concepts I want you to get from this lesson is that if you draw a radius to a tangent, it'll always make a 90-degree angle, which we quite often use to make right triangles, which involve Pythagorean theorem. The second main point I want you to get is that if two tangents come from the same point, those two tangents have to be congruent. Okay? So if you guys have any questions, please feel free to ask me either in class or send me an email. I'd be glad to help you in any way that I can. I hope this lesson wasn't too tough for you. It's a nice little introduction to our last chapter. And trust me, you might think, okay, how can circles be tough? Well, it can get tough. So be prepared for that. All right. Hope you guys are doing well. I'll see you real soon. Have a good one.